Hi, I'm Bailey with MyMathExperts, and today I'm going to help you solve the following problem. Which quadrants contain the solutions to this system of inequalities? And then they give you a system of inequalities. So first things first, we're going to need to graph these if we're going to figure out which quadrants contain the solutions to this system. So I typically like to get these in slope-intercept form. So slope-intercept form. And if you need a reminder about what that looks like, that's y equals mx plus b, where m represents the slope and b represents the y-intercept. So if you put these in slope-intercept form, it's going to be really easy to graph them because you can start with the y-intercept and then go with the slope from there. So on this first guy, we have y minus 2x is less than or equal to -3. Just treat this less than or equal sign as if it were an equal sign for now. So if we want to get y by itself, because in slope-intercept form, y is by itself, looks like we're going to have to add 2x to both sides. So we're going to get y is less than or equal to -3 plus 2x. And now we are in slope-intercept form because our y is by itself. We have our constant, which is our -3, and then we have our x term, which is our 2x. So that looks like our y-intercept is going to be -3. So I'm actually going to change colors here. Let's do red. We're going to be at -3, and then our slope is 2. So if we think about rise over run, that's a 2 over 1. So we can go up 2 over 1, up 2 over 1. And then this part, when we start connecting these dots, that's where this less than or equal to part comes into play. So since it has the or equal to part here, that means that we're going to be a solid line connecting all of these, as opposed to a dotted line. If it were just less than, it would be a dotted line. But since it has the equal to part, that means it's a solid line as opposed to dotted. And then we're saying we are less than, our y is less than all these. So that means we are going to be looking below our line. So I'm just going to kind of go ahead and make like a little trapezoid here of values that would be included. You can also test points. I know that some math teachers suggest testing points to see what side of the line you could shade on. So we can do that too, just to make sure that we're shading the right side here. So let's test, looks like 5, 0, for example, would be a point in here. Let's test that and make sure it works. So if we're looking at the point 5, 0, that means y is 0. -3 plus 2 times 5, our x value is 5. 0 is less than or equal to -3 plus 10. 0 is less than or equal to 7. That is true. So that makes sure that we're on the right side. If we tested a point, let's say like over here, we would get a false statement. So let me just kind of show you what that would look like. Let's test something like -5, 0. That's on the other side. So that would be, we could test that the same way, except now we'd be saying 0 is less than or equal to -13, which it is not. It is greater than -13. So that tells you that this is not the correct side. You will not get correct solutions. So that's another way you can tell. It's totally up to you what you prefer. Let's see. Okay, and now let's graph the second one here. This one looks like it's going to be a little bit tougher. So I'm just going to kind of highlight. We're going to say that was our red one. And then let's go to our bottom one here. I'm just going to kind of draw something over here that says we're doing this one down here. 3y plus x is greater than or equal to -4. So again, we want to get y by itself. So first thing we're going to have to do is subtract x from both sides. So 3y is greater than or equal to -4 minus x. And then we're going to have to divide both sides by 3. Y is greater than or equal to, I'm going to split these into 2 terms just because it'll look more like slope-intercept form that way. So I'm going to say -4/3 minus 1/3 x. Because this is always, you can always think about there's a 1 in front of any number, right? Anything can be multiplied by 1 and still be the same number. Okay, so now to graph this one, let's graph this one in blue. We're going to start at -4/3 because that's our y-intercept. That's the one that doesn't have an x with it. So -4/3 is a little bit more than -1. So that would be like maybe right here. And then our slope is going to be -1/3. So we could say down 1 over 3. So somewhere like that. Down 1 over 3, maybe somewhere like that. Cool. And then again, in terms of connecting these points, this also has a or equal to part to it. So that's going to be a solid line. Maybe something like that. Doesn't have to be perfect. And then this time, y is greater than or equal to this stuff. So that means we're going to be shading on top. So that's going to be like all of this stuff. I always think this is kind of fun. I like coloring. You get to just kind of take a breather from math and color for a little bit. I highly recommend, if you do this on paper, I highly recommend getting like some markers or colored pencils or highlighters or something, because it really does help you see like the overlap if they're different colors. Okay, cool. So that's good enough. Now the solution to the system of inequalities is going to be where they overlap. So this kind of purple zone that I'll draw here is going to be the solution set. Okay, so we have our solution set graphed. Now the last thing we need to know is how the quadrants are named. So I always think about, it's like if you measure an angle, like the positive x-axis is the like starting point, and then you go around counterclockwise. So I always think if you're starting here, it goes around counterclockwise. If you haven't already seen applications for that in your math class, you will in the future. So keep that in mind. So basically in that order, that means this is quadrant 1, this is quadrant 2, this is quadrant 3, this is quadrant 4. So it looks like our solution set here is we definitely have some stuff in quadrant 1. Doesn't look like we have any in quadrant 2. Doesn't look like we have any in quadrant 3. And then it does look like we have some in quadrant 4. Again, this is just the purple zone. This is just the overlapping zone. So I would say 1 and 4, which is answer A. So perfect. Thanks for sticking along with me on this one. And I hope that helped.